Now let's take a look at some problems where our denominators are a little bit more complicated at the start. In such cases, to figure out what you're going to need to multiply by the top and bottom of each fraction, it can help to factor your denominators. In the case of our first fraction here, we have 7x on the top, and when we factor our denominator, to multiply to be a positive 16 and add up to negative 8, we would need negative 4 and negative 4. So we have x minus 4 times x minus 4. Or if you feel like it, you could write it as x minus 4 squared. In our second fraction, we can factor out a 3 from both terms in the denominator, leaving us with 3 times x minus 4. Now, when you're figuring out what you need to multiply by the top and bottom of each fraction to get your common denominator, you want to look at that other fraction and think, what does that fraction have that my current fraction is missing? So when we're trying to decide what we need to multiply by the top and bottom of our first fraction, we look over at the denominator of the second one, where it has 3 times x minus 4. Our first fraction already has x minus 4 in the bottom. We don't need to multiply by that, but it's missing the 3. So we need to multiply by a 3 on the top and bottom of that fraction. Now, when we're thinking about our second fraction, for our second fraction, here, to figure out, that was not what I was supposed to do. To figure out what we multiply by the top and bottom of our second fraction, we need to look at the bottom of the first fraction and see what that has that this one is missing. Now the first fraction has x minus 4 twice. This second fraction only has x minus 4 once. To get the same thing, we need another x minus 4. So we're going to multiply the top and bottom of this fraction by x minus 4. So to figure out what you need to multiply by the top and bottom of each fraction, you look at the other fraction and see what does that one have that my current fraction is missing in the denominator. Now putting this together, we're going to end up with the denominator for both fractions of 3 times x minus 4 times x minus 4. Next, we need to multiply our numerators and see if we have any like terms to combine. From the left, 3 times 7x is 21x. From the right, we distribute the 5x. 5x times x is 5x squared. 5x times minus 4 is minus 20x. It looks like we do have some like terms we can combine there. 21x minus 20x is x, so that gives us 5x plus x, 5x squared plus x in the numerator, and then 3 times x minus 4 times x minus 4 in the denominator. And we'll go ahead and factor the top to see if there's anything we could do to reduce it. In this case, we could factor out an x, and we'd be left with x times 5x plus 1. In our denominator, we have 3 times x minus 4 times x minus 4. It looks like we don't have any common factors in the numerator and denominator, so this would be our final answer. Let's take a look at the next problem, where we're subtracting fractions. Problems like this, where you're subtracting fractions, are one of the places where my students will most commonly make mistakes, particularly with negative signs in the second fraction. What I've taught my students to do sometimes that helps them to not make so many negative sign mistakes is, when you have a problem with subtracting fractions, let's change it from a subtraction problem to an addition problem. And when we do that, we need to change the signs on top of that second fraction. So instead of positive y plus 4, we'll have negative y minus 4. Again, my only reason for doing this is that that's going to help me to not make so many negative sign mistakes later on. So now we have y plus 5 on top of the first fraction. In the denominator, y squared plus 2y minus 3. When we factor that, we'll have two parentheses with y at the beginning of each one. To multiply to be negative 3, but add up to a positive 2, we have y plus 3 times y minus 1. Now we factor the denominator of that second fraction. Again, we'll have two parentheses starting with y squared, or y in each one. To multiply to be a positive 2 and add up to negative 3, we need a minus 2 and a minus 1. So now when we're figuring out what we need to multiply by the top and bottom of our first fraction, we see that that second fraction has a y minus 2 that the bottom of the first one is missing. So we need to multiply the top and bottom of this fraction by y minus 2. When we're thinking about what to multiply by the top and bottom of the second fraction, we look at the denominator of our first fraction, and we see that it has a y plus 3 that this one is missing. So we're going to multiply the top and bottom of this one by y plus 3. Now, putting these together, we're going to have a denominator of y minus 2 times y plus 3 times y minus 1. The order of the factors doesn't particularly matter. If you put y minus 2 times y minus 1 times y plus 3, that's just as good. Now in this example, we're going to have some more multiplying and combining like terms to do. From our first fraction, y minus 2 times y plus 5, we do the FOIL method. The first terms, y times y, is y squared. The outside terms, y times 5, we have 5y. The inside terms, negative 2 times y, we have minus 2y. The last terms, negative 2 times 5, we have minus 10. From the top of the right side, we do the FOIL method again. Negative y times y, we have minus y squared. Negative y times 3, we have minus 3y. Negative 4 times y, we have minus 4y. Negative 4 times 3, we have minus 12. Now in this case, our denominator stays the same. We're going to have a lot of combining like terms to do on the top. Let's see, when we look at this, we have a y squared and a minus y squared that end up canceling each other out. Then we have 5y minus 2y minus 3y minus 4y, which all results in 4y. Then for our constant terms, we have a negative 10 and a minus 12, which gives us minus 22. Now we can factor a 2 out on the top. We would have 2 times y minus 11, leaving our denominator alone as y minus 2 times y plus 3 times y minus 1. There's nothing we can cancel out from the top and the bottom, so that would be our final answer. If you'd like to try the next problems on your own, pause the video now and resume when you're ready to see the solution. The denominator of our first fraction here is a difference of squares. When we factor it, we would have w plus 5 times w minus 5. The denominator of our second fraction, we factor out a greatest common factor of w, and we would have w times w minus 5. So the first fraction on the denominator is missing the w that's in the bottom of that second fraction. So we're going to multiply the top and bottom of that first fraction by w. The second fraction is missing the w plus 5 that's on the bottom of the first fraction. So we're going to multiply the top and bottom of that one by w plus 5. This is going to leave us with a common denominator of w times w plus 5 times w minus 5. In our numerator, w times w plus 5, we have w squared plus 5w. And from the second fraction, 4w times w plus 5, we have plus 4 w squared plus 20w. We combine the like terms in the numerator and we would have 5w squared plus 25w. In our denominator, we still have w times w plus 5 times w minus 5. To factor the numerator to see if we can reduce it, we factor out a greatest common factor of 5w, and we're left with 5w times w plus 5. In our denominator, for right now, we still have w times w plus 5 times w minus 5. And in this case, it looks like there's a couple of things we'll be able to do to reduce it. We have a w plus 5 we can cancel out of the top and the bottom, and we have w we can cancel out from the top and the bottom. This leaves us with 5 over w minus 5 for our final answer. Now looking at our next problem, as I mentioned before, a trick that I found helps my students to not make so many negative sign mistakes is to change a subtraction problem to an addition problem. So I'll do that here. And when you do that, you change the sign on top of that second fraction from 5 to negative 5. And now we treat it just as we would a regular addition problem. In the denominator of our first fraction, when we factor it, to multiply to be a positive 10 and add up to a minus 7, we would have x minus 2 times x minus 5. In the denominator of the second fraction, we have a difference of squares. When we factor it, we would get x plus 5 times x minus 5. So the denominator of our first fraction is missing the x plus 5 that's on the bottom of the second fraction. So we multiply the top and bottom of that fraction by x plus 5. The denominator of the second fraction is missing the x minus 2 that's on the bottom of the first fraction. So we'll multiply the top and bottom of that one by x minus 2. And this is going to leave us with a common denominator of x plus 5 times x minus 2 times x minus 5. In the numerator on the left side, we use the FOIL method to multiply x plus 5 times x plus 4. X times x is x squared. X times 4, we have plus 4x. 5 times x, we have plus 5x. 5 times 4, we have plus 20. On the right side, negative 5 times x is minus 5x. Negative 5 times negative 2 is plus 10. We combine the like terms and we would have x squared, then 4x plus 5x minus 5x, we have plus 4x. 20 plus 10, we have plus 30. In our denominator, we still have x plus 5 times x minus 2 times x minus 5. In this case, there's nothing we can multiply to get 30 that adds up to 4, so we can't factor it, and there's nothing we can do to reduce it. We're done with this problem.